Hi friends, so let's continue with our question and answer session for reflection and refraction. Which lens would you prefer for reading small letters from dictionary? See, we would use convex lens as it magnifies the objects placed between 0 and f. Okay, because see, when you take the convex lens close to the letter object will fall between the optical center O and focal length f, and therefore because of that it gets magnified so that you can read the small letters easily because the image will be big. That's why we will use convex lens. Okay, we wish to get an erect image using the concave mirror. Okay, a focal length 15 centimeter. What should be the object distance? What is the nature of image? See, from your ray diagrams which you have studied before, and see the ray diagram here, if you place the object between the pole and the focal length of the concave mirror, only then will you get an erect image. Okay, so to get an erect image you have to place the object between the pole and the focal length. Okay, so object should be between f and o. Okay, image type will be virtual, it will be erect, and it will be enlarged. Name the mirror used for headlights and rear view mirrors. Okay, for headlights we use concave mirror. Why means, if you look at this ray diagram, if you put the lamp at the focal point of the concave mirror, all the rays emanating from this lamp will hit the mirror, and since it is coming from the focus, the light will be reflected parallel to the principal axis. So it will create a parallel beam. That is why we use a concave mirror for headlights. What about rear view mirrors? We use convex mirror for the rear view mirror, because see, if there is a big bus which is just behind us, the image formed due to the concave mirror will be smaller, so that you can see the whole of the bus in your mirror. That is why we use the convex mirror. You can see that a ray going parallel to the principal axis will get reflected such that it is going through focus. You will see that the ray which is going in the direction which is passing to the center of curvature will reflect as is, right? And these two rays which appear to sort of emerge out of this top part of the image which is formed here. So image formed is a smaller image than the object, which allows us to see the whole object. Therefore we use convex mirror for the rear view mirrors. Okay, object of 5 centimeter length. So object is 5 centimeter in length, held at 25 centimeter away from a converging lens. What is the converging lens? We know that convex lens is a converging lens. Okay, and its focal length 10 centimeter. Draw the ray diagram and give us the position, size, and the nature of image. You can see here's the ray diagram. Okay, see, they have given that the focal length is 10 centimeter, but we are drawing a small ray diagram just for representation. Okay, so we are dividing all distances by 10. So 10 centimeter means we are making focal length 1 centimeter. So if you take a scale and measure, this focal length will not be 10 centimeter, it will be just 1 centimeter. But if we try to draw the image at 10 centimeter, image will become very big. Okay, that is why we have ensured that we draw a small image of focal length 1 centimeter. And they also say that they are placing the object at 25 centimeter. Okay, we have drawn it such that it is placed at 2.5 centimeter. So all distances are divided by 10 to make the image small. Okay, and one more thing is, when you are using the lens formula, there we are substituting the actual numbers. Only for drawing the image we are substituting smaller numbers. Okay, you see in the ray diagram that the object is held 25 centimeter away and the focal length is 10 centimeter. If the focal length is 10 centimeter, the center of curvature will be twice the focal length, that is 20, correct? But the object is at 25 centimeter. 25 means it's beyond the center of curvature. So when the object is beyond the center of curvature, a ray which is parallel gets bent and goes through the focus. A ray which is going through the optic center goes in the same direction without any change in direction. They two intersect and the image is formed between the focus and the center of curvature on the other side. okay, and it's a diminished image. Okay, so what is the size of the image? To find out that, and what is the distance of the image? To find out that, we use our lens formula. Lens formula is 1 by v minus 1 by u equal to 1 by f. 1 by v is equal to 1 by f plus 1 by u. What is f? For convex lens, focal length is positive. So 10 centimeter, f is positive. So we have substituted that, and the object is held 25 centimeter away. 25 centimeter away along which axis? Along the negative x-axis. So we have substituted minus 25 here. So 1 by 10 minus 1 by 25. What is the LCM of 10 and 25? 25 2s are 50, 10 5s are 50. So it is LCM is 50, correct? So to make the denominator LCM, we have to multiply by 5, numerator also multiply by 5, you will get 5. 25 to make it LCM, multiply it by 2 denominator, 2 in the numerator, you will get 2 by 50. So 5 minus 2 by 50 and 50 by 3. So V is 1 by V is 3 by 50. So V is 50 by 3, that is 16.66 centimeter. So as you can see, the image is formed along the positive. It is positive 16.66. It is along the positive x-axis. Okay, positive x-axis 16.66 centimeter. It is formed. What is the magnification? It is h by h dash by h, that is equal to v by u, which is v, we have calculated it to be 16.66. Object distance minus 25, we have done that. That is equal to 16.66 by 25. If you take the calculator and work this out, you will get minus 0.66, which means it is a smaller image. Minus means it is inverted also, right? So if the object length is 5 centimeter, what is the image length? Image length is h dash is equal to 0.66 minus 0.66 into h, okay, into 5. That is, if you take the calculator again, you'll get minus 3.33 centimeter. Okay, so image is smaller, it is real, and it is inverted. Next question. Concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. How far is the object placed? Okay, so again look at the rough image diagram. Any convex lens, the object is, if it has a focal length of 15 centimeter and the image formed is 10 centimeter, right? The situation is like this. You have a concave lens here, you have the object here, a ray which goes parallel gets scattered, diverged, right? And the diverged appears to come from the focal length. Okay, any ray which goes directly to the optical center keeps on going as is. Okay, so if you backtrace both of them, they will form an image here. Okay, for a concave lens, if they say focal length is 15, we have to take f as minus 15. Why? Because it's concave. Okay, and what is they have given the image, the forms image at 10 centimeter. 10 centimeter means image is also formed, as you can see from this ray diagram, on the negative x-axis. So you have to put v equal to minus 10, and they are asking how far is the object placed, which means they are asking u is equal to what. Okay, to calculate the u, we use the lens formula again. 1 by v minus 1 by u is equal to 1 by f, which means if you send 1 by u minus to the other side and take the 1 by f to this side, you will get 1 by u is equal to 1 by v minus 1 by f. Okay, and what do you have for v? We have minus 10 centimeter. We are substituting minus 1 upon, what do we have for f? Minus 15. We are substituting that. This minus and this minus becomes plus. You will get 1 by 15 here. And 1 by minus 10 is minus 1 by 10. Okay, and here 15 and 10, what is the LCM? 15 2s are 30, which is divisible by 10 also. Correct? No. So 30 is the LCM. To make this the LCM, you have to multiply denominator and numerator by 2. So you will multiply 2, and here you have to multiply by 3. So minus 3. So minus 1 by 30. So 1 by u is equal to minus 1 by 30, which means u is equal to minus 30. Okay, which means you have to place the object 30 centimeter along the negative x-axis. That is the answer. Okay, next question. Object placed at 10 centimeter from a convex mirror. Okay, whenever you want to write a ray diagram, you must ensure you are using correct lens, correct mirror. Here they are saying 10 centimeter from a convex mirror, of focal length 15 centimeter, position and nature of the image is equal to what? Okay, remember, if you look at this ray diagram, any object placed in front of the convex mirror, one ray will go parallel to the principal axis and it will reflect as though it is coming from F, and any ray shot in the direction of C passing through C will bounce back in the same direction, and these two rays will appear to diverge out of this point, which is the image, and the image is always smaller than the object. Okay, so again using the mirror formula, see, you should not use the lens formula, it's a convex mirror. So what is a mirror formula? 1 plus u, 1 upon v plus 1 upon u equal to 1 upon f. Okay, now 10 centimeter means 10 centimeter along the negative x, so u is equal to minus 10. For a convex mirror, the focal length is positive, right? Because you can see that for a convex mirror, center of curvature is here, and midpoint between the pole and the center of curvature is the focal point. So it is along the positive x-axis. So for a convex mirror, the focal length is positive, and they say that it is 15 centimeter. Okay, they are asking the image distance. So to get the image distance, we say 1 by upon v is equal to 1 upon f minus 1 upon u. Substitute for f. Okay, when you substitute for f, you get 15, and when you substitute for u, you get minus 10. Minus and minus will become plus. So 1 by 15 plus 1 by 10. Again, LCM is 30. So denominator is 15, multiply by 2, multiply by 2, you'll get 2. Denominator is 10, multiply by 3 to get 30 LCM. So you'll get 5 by 30, which is 1 upon 6. Okay, because 5 6 are 30. Okay, now 1 upon u is 1 by 6. So v is equal to 6 centimeter. That is positive. So the image will be formed at positive 6 centimeter along the positive x-axis. Okay, the image is erect, it is virtual, and it is diminished at 6 centimeter along the positive x. Okay, next question. Magnification of mirror is equal to 1 means what? See, magnification of mirror, m is equal to h dash by h is equal to 1 means h dash is equal to h, which means image size is equal to object size. So when a mirror produces an image size which is same as object size, we can say that magnification is 1. That's all. Next question. Object 5 centimeter length is placed 20 centimeter in front of a convex mirror. Okay, again the same case. You can use the same ray diagram. Convex mirror of radius of curvature. This time they have given radius of curvature. What is the image position and size? See, ray diagram is similar to 84. The problem 84 we did, right? That is the ray diagram is similar. Okay. Given that your R, radius of curvature, is 30 centimeter, which is positive for convex mirror. This is a convex mirror. The focal length is radius of curvature by 2, that is 30 by 2, that is 15 centimeter. And they have said that you have kept the object 20 centimeter in front of the convex mirror, which is along the negative x-axis, right? So you will get u is equal to minus 20 centimeter. Okay, minus because it's placed along the negative x-axis. If you want to apply the mirror formula, which is 1, because this is a convex mirror, so 1 upon v plus 1 upon u is equal to 1 upon f. Be very careful while taking the mirror formula or the lens formula. Mirror formula is 1 upon v plus 1 upon u is equal to 1 upon f. So 1 upon v is equal to 1 upon f minus 1 upon u. So focal length in this case is 15 centimeter substituted, and u is equal to minus 20 substituted. So you'll get 1 by 15 plus 1 by 20. What is the LCM? 22s are 40. It doesn't go in 15. 23s are 60 and 15 4s are 60. Okay. So you get 60, and to make the denominator same, you have to multiply it by 4, and here you have to multiply it by 3. You will get 7 by 60, which implies v is equal to 60 by 7, that is 8.57 centimeter. So that is the image distance along the positive x-axis. Okay, so what is the magnification? Magnification is minus u by v. Why minus u by v? Because this is a mirror. Okay, so minus u by v, v is minus v is 8 point, the minus sign is already there, v is 8.57 and u is minus 20, right? We are just substituting. You will get 0.428 because this minus and this minus will cancel, which means you will get a virtual image, you will get an erect image, and you will get a diminished image. Okay, next question. Object of size 7 centimeter is placed 27 centimeter in front of a concave mirror. Okay, look at the ray diagram. You have to draw the appropriate ray diagram. Concave mirror. Okay, of focal length 18 centimeter. What distance should the screen be placed for a sharp image? Which means they are asking what is the image distance and what is the size of the image. Given that the size of the object h is 7 centimeter. Okay, u is minus 27. It is placed in front of a concave mirror. Correct? Front means along the negative x-axis. So it is minus 27. Focal length, again for a concave mirror, focal length is negative. 18 centimeter means you have to take it as minus 18 centimeter. Okay. So it is very important that once you read this problem statement, you draw a rough ray diagram and you ensure the sign of U, F, V, H, all the signs you should ensure that it is proper. And you should use the right formula because it's a concave mirror, it's a mirror, we are using the mirror formula. Okay, if you don't do all these steps properly, then there will be mistakes. Okay, so mirror formula is 1 by v plus 1 by u is equal to 1 upon f. So you want the image distance, so 1 by v is equal to 1 by f minus 1 by u. What is f? F is 27 centimeter. Okay, f is focal length is 18, minus 18, we are substituted that. U is equal to minus 27, we are substituted that. This minus and minus will give you plus, and this will give you minus 1 by 18. Okay, so the LCM is 54 because 18 3s are 54 and 27 2s are 54. 54 is the LCM, and to make this denominator same as LCM, you have to multiply by 2. Both numerator and denominator. Here you have to multiply by 3. You will get minus 1 by 54. So V is minus 54 centimeter. That is the image is minus 54 centimeter, which is 54 centimeter along the negative x. So you have to place the screen at minus 54 centimeter to get the sharp image. And what is the magnification? It is h by h dash minus v by u. Minus v by u because this is a mirror magnification. Okay, not lens magnification. Lens magnification, it is just v by u. Mirror magnification minus v by u. So minus of, what is v? Minus 54. You have already calculated, you substituted. U minus 27. So minus 27 minus 54, it becomes positive, but there is another negative sign here. So you get minus 2. Okay. So the image size is double, but it is inverted. That's why you are getting minus 2. And what is the image size? Image size is equal to minus 2 into object size, that is minus 2 into 7, that is minus 14 centimeter. Okay. Next question. Lens of power minus 2 diopter. What is the focal length? What is the type of the lens? See, the focal length is nothing but 1 by p. See, p is equal to 1 by f. If you do cross multiplication, f is 1 by p. Okay. So if the power is minus 2, the focal length is 1 upon 1 divided by minus 2. Okay, you'll get minus 0.5 meter. Since it is minus, it's a concave lens because the focal length is negative. Okay, next question. Doctor prescribed lens of 1.5 diopter. Focal length is equal to what? Okay, the focal length is equal to 1 upon power, okay, which is 1 upon 1.5, which you will get as positive 0.66 meter. Since it is positive focal length 0.66, it's a convex lens since f is positive. Hence, it is a converging lens because it's convex. Okay, convex lens always is a converging lens.